Hello world! So welcome to the second episode of my series on how to get at least a C in C++. So today we're going to go over chapter 2 of the book, and I'm actually going to split this into two chapters because there's just so much information to cover, and I tried to put everything into one chapter and it was like 30 or 40 minutes. So let's just work on putting this over under 10 minutes. Okay, so in this episode, I'm going to introduce you guys to variables, literals, and data types. And in the next episode, I'm going to go over arithmetic operators, variable scopes, and whatever miscellaneous topics that I didn't cover in this one. And then I'll walk you guys how to write a program involving those few things. Alright, so in programming, we have to have a way of storing and manipulating values, and with that, we have to use variables. Right? If you guys have taken an algebra course before, you'll know that variables are just symbols that represent another value. And do you guys remember how I talked about programmer-defined symbols last episode? Well, variables are a form of programmer-defined symbols. They're actually just memory that's reserved or allocated so that we can store data and values into them. Literals are basically just the values that we assign to variables. So an example would be like assigning the number 3 to a variable we've made up called x, where the integer 3 is a literal. We're going to be able to change and manipulate variables however we wish, but we aren't going to be able to do that with something called named constants. So named constants or constants are another form of programmer-defined symbols, but after you assign values to them, which I'll show you how to do a little later, it can't be altered during the execution of the program. And you may be wondering why you'd actually want to use constants in your code then, when you could just hardcode the literals or just use variables instead, right? But constants actually allow you to use a value over and over again in your code without risking it being changed and affecting later operations in your program. They also add meaningful descriptions as to why a certain value is used in your code. Next, I'm going to talk about variable assignments and initialization. So when we create variables in C++, we're going to get the opportunity to name it and assign a value to it. So first, when creating a variable, we must declare it, which means that we're going to assign the variable a data type. So those are going to be either integers, floating points, characters, strings, or booleans, but I'll go more in depth into data types in a minute. So the next step is to define the variable, which basically is just naming it. So there are proper ways to name a variable, and those rules are going to be called naming conventions. It's just simple rules that say that variable names shouldn't start with underscores or any other symbols. You should start your variables with lowercase letters. They should be relatively short but have meaningful names, and if they're going to be made up of multiple words, you should use something called camel case notation, which basically dictates that you start variable names with a lowercase letter, and for each word that's compounded into the variable name after the first word, you're going to start it with a capital letter. It sounds complicated, but in the example right here, we have an integer type variable called first number. And notice how the f in first is lowercase, while the n in number is uppercase. You can basically choose any name you want, you just aren't allowed to use any of the keywords in C++ because the compiler is going to stop and try to recognize it for its intended meaning. So here, I have all the lists of keywords in C++, and as we go on through this course, I'll introduce you guys to the meanings and the uses of this word. So next, we have to initialize our variable, which means that you're just going to assign a value to it. So there's actually two ways to do this. So here, let me make an example. So let's have integer data types called first number, and we could assign the value onto the same line, so let's just give it a value of 10. Or a second way, you could just declare and define a variable. So let's have an int one called second number. Again, notice the camel case notation, right? And anytime after this point of declaration and defining it, you can go ahead and initialize a value to it. So this could be useful when you're just trying to, let's say, take input from the user. Or in this case, we could just give it a value right now. So second number equals 5. One thing that you guys should note is that second number, the variable name, or even up here in first number, is going to be on the left-hand side of the operator. This is going to be called the L value, and if you guys haven't noticed, L stands for left. It's going to be on the left-hand side of the equal sign, which is called the assignment operator. So of course, It's an operator that we use to assign values to the L value. The value on the right is going to be called the R value. If you guys haven't noticed, the R stands for right. And this doesn't necessarily have to be literals. You could go ahead and give it, like, let's say the value of first number right here. Or you could give it a value of another constant, let's say. So the declaration of constants are going to be similar to the declaration of variables, but not exactly. So constants are always going to be preceded with a keyword const, following with a data type, then the name you assign it, and lastly you're going to initialize it. And with constants, you have to initialize it on the same line that you declare it on, and you don't get the option to do it on a different line or change its value when you do. And typically the naming convention of constants are going to be like variables, except the letters in the names aren't going to be in all caps, or they are going to be in all caps, which also means that camel case notation is out of the picture. So when we compound multiple words in the name of a constant, we're actually going to separate them with underscores. So let's say we have a constant, let's make it a double, and let's make it like a tax rate, let's say. So tax is going to be in all caps, underscore rates, right, equals, here it's like 0.0875, right? And that's basically it. So anywhere after this point, we could go ahead and use tax rate as like an actual value. So let's say we have an operation, I don't know, double sales tax. We can make sales tax equal, let's have like, let's say a price of a $5 item times tax rate, and then you just be multiplying 5 by 0.0875. So yeah, those are just constants. So moving on to data types. So data types are the classification or type of a piece of data, hence the name data type. Now, there are going to be 5 general categories of data types. So those are going to be integers, characters, strings, floating points, and booleans. So integers, or ints, are whole numbers that can either be negative or positive. So there are going to be 8 different integer data types, but the best table I could find online only has 6 listed. So the first one we have is called a short int, which is just an integer that ranges from negative 32,768 to positive 32,767, and an unsigned short int ranges from 0 to 65,535. You don't have to memorize these values. So notice how the short and the unsigned short int both hold the same number of values, and they both take up the same amount of memory. It's just that the unsigned short is capable of storing a higher value because it's unsigned, which means that it just can't store negative values. So the same pattern holds for the rest, the int and the unsigned int, the long and the unsigned long, and the two that aren't listed on the table, the long ints, which are 8 bytes and range from about negative 9 quintillion to positive 9 quintillion, and the unsigned long ints, which are also 8 bytes and range from 0 to about 18 quintillion. Really, the only reason why you would want to use the 7 other data types that aren't int would be just if you're just trying to consciously save memory, therefore by using the short data types that take up half the memory of an int, or if you're going to use a really large value. But again, this isn't going to be in the scope of the series, and you aren't going to typically use it in lower division programming courses because professors aren't going to make you conserve memory or anything, and they're also probably not going to make you use values larger than 2 million. So using the regular int is going to be fine for now. And you guys may be wondering what the ranges have to do with the data types themselves, and they're just the largest numerical value or the smallest numerical value that something of that memory size is able to hold. And you may be dying to know what happens when you take a variable out of its range. So first, let's declare a value of type short, let's say right here, and then we're going to call it overflow var. Notice the camel case notation. Overflow is one word, by the way, and the v in var, which also stands for variable, but that doesn't really matter, is going to be capitalized. And let's assign it the largest value that a short can hold, so 32,767. And let's see what happens when we add 1 to that, which would make it go out of its range, right? So overflow var equals overflow var, which is the highest number it can hold, plus 1. And let's go ahead and make a cout statement that prints it. So the value of overflow var is, alright, so we're going to end the quote, compound it, so overflow var, and then end L. Let's go ahead and compile it and see what it equals. Okay, so right here we have the value, and it's going to be the lowest range, right? So every time you have a data type that goes out of its range, it's just going to cycle back to the small size. So let's say if we're going to subtract it from negative 32,768, you're actually going to get the highest range, and that's just going to hold true for every other data type. So let's move on to character data types. So character data types are single character values. So this could be anything from lowercase to uppercase letters, ampersands, exclamation points, anything else that's just one character. So when character values are stored as variables, the processor is going to store them as integers. So each character has its own integer to represent it, which is also called an ASCII code. So ASCII just stands for American Standard Code for Information Interchange. So for example, the ASCII code for the capital letter A is 65, while the one for lowercase a is 97. You honestly don't need to know the codes for these values. You could always just look them up. I just want to familiarize you guys with this, since we're eventually going to use the integers in later concepts. So let me just show you guys how to declare a character. So it's just going to be car, the name of it, let's call it a letter, equals a, right? So notice how I'm only using one single quote around it, right? So since character data types are only capable of storing one character in a memory location, we have to use a data type called a string to allow us to store multi-character values. So since strings are able to store more characters in them than car data types, this means that the way they store memory in the CPU is going to be different. The only other difference is that you're going to surround character values with single quotes and then the string ones with double quotes during initialization. Pretty much anything can be stored into a string, from words to sentences to symbols and even letters. So going back to what I said about the difference of memory storage between the two, if let's say the letter A is stored into a character type variable, and the same letter A was stored into a string type variable. So let me just show you how to do that. It's just going to be string letter equals double quote A, right? It's basically same thing. The only difference is the keyword and the double quotes. So the string, the way that it would be saved in memory is that it would just have an extra byte at the end, right? So it would be stored with with the ASCII code 65, like I said earlier, but the string's gonna have a 0 at the end. So the 0 is gonna be called a null terminator, and a null terminator is just an extra byte compounded to the end of the memory, just to let the CPU know that the string has ended. When we use strings in our code, we must use the string header file, which personally I think is kind of stupid, because like, why wouldn't strings be a built-in data type in C++, but whatever. So the string header file, we have an example of it down here, and of course I use it up here again for us to be able to use strings. This is just gonna let us be able to use strings in our program. Okay, so floating point data types are just numbers with fractions and decimals. So like ints, there are different floating point data types, whereas single precision or float would take the least amount of memory and have the smallest range, and double and long double, depending on your specific compiler, will have the same range or different ranges. So just like in using ints, if you guys want to consciously conserve memory, go ahead and use floats, but in general we're just gonna go ahead and use doubles. So booleans are just data types that can contain one of two values, either true, which is going to be stored as 1, or false, which is going to be stored as 0. We aren't really going to deal with booleans for now, but we'll save it for later chapters that we're going to deal with. So let me just initialize and declare a boolean value. So it's going to be bool, and let's call it truth equals true, right? If you guys compile it and we print it out into an output, then we're gonna get like a 1 that would appear. So let's see out the value of true is, and then oops, it's actually truth is, and then truth. Let's see what the compiler gives us. And right here we have 1, if you guys can see that. Sorry, it's really small, by the way. Alright, so I actually hit the 15-minute mark for this episode. This is actually way better than I did earlier. I hit like 20, but yeah, super sorry about that, guys. So that was gonna be the first part of chapter 2, and I will be back for the rest of it in the next episode. Alright, thank you. Also, real quick, one last thing that I forgot to mention. I will post a PDF or like a Google Doc of these notes somewhere in the description box below, just if you guys didn't catch up on what I said. Alright, cool. Thank you, for real now. Bye.